All right, so we're live now, and so we are here with Max Kordek, the co-founder and CEO of Lisk. I had the opportunity of meeting him in Berlin, 2019, and post Web Summit. Really cool stuff happening with Lisk again. And if you guys are, are lovers of JavaScript, and if you wanted a framework to build blockchains on, Lisk was actually the go-to framework back in the day. And now that so much things are happening, so many blockchains are coming about. So many side chains, so many actual chains, main chains are coming about. It's so difficult to see what will last and what not will last. And so as Polkadot, came in for interoperability platforms, interoperability seems to be inevitable, right? And we've seen that, frustrating the people like me that I can't port assets to different chain, or I have to bridge assets to a different chain, even if it's for stable coins, even if it's for tokens and assets that are on multiple chains and networks. Max has been working on blockchain interoperability and has certain views and mindsets on how it can lead to mass adoption. And this might be a key here. And how is Lisk kind of like doing their efforts towards it? They have a great big community. I was super happy to actually attend that event. It was one of the best events that I could say that I attended in a very closed, cozy place. But it was amazing. So I'm gonna give it over to Max. Pleasure having you here, Max. I'm gonna be in the backstage, and so you can introduce yourself and and share your screen whenever you want to. Yeah. Thank you so much.
Perfect. Yeah, nice. Thank you for having me. It's a pleasure to being at Incrypted. It's, I think, one of my first events I'm doing entirely online, so I'm excited to see how it goes. Let me share my screen right away. I will have one or two slides where I present who I am and what Lisk is doing. So let me quickly know in the chat if you see my screen and if you can hear me right. Okay, perfect. Then let's move over to the presentation. So yeah, welcome to my talk. It's all about blockchain interoperability, which in my opinion is the key to mass adoption for blockchain technology. My name is Max Kordek. I'm the CEO and co-founder of Lisk. And at Lisk, we offer JavaScript developers all required tools to build dApps on their own native blockchain. And we currently work on an interoperability protocol to connect then these dApps back to the Lisk blockchain. And yeah, you will hear about this more in this talk here today. We are like a very old project back from 2016. We have a veteran team of 40 people and currently funding of over $150 million. We are overseen by a Swiss nonprofit foundation, the Lisk Foundation, and have also an office in Berlin where the main development, marketing, research efforts are being conducted from. So let's jump right into it. What will you hear today from me? So first of all, I will tell you more about generally blockchain interoperability and what kind of solutions and methods are available on the market today. Then I will jump into Lisk interoperability, what kind of solution we are currently researching. We'll tell you a little bit about the advantages, what blockchain interoperability can bring to the industry overall, but also the advantages of having your dApp on your own blockchain, which is then just connected via an interoperability protocol to a wider ecosystem, and where you can get some more information about this whole topic in May. So let's start with blockchain interoperability and what it is. So nowadays you have like quite a few blockchain platforms or ecosystems. You have Ethereum, Polkadot, Lisk, Bitcoin. And back in the day when the internet started, intranets were very popular, where each company had their own intranet essentially. But this never reached like true mass adoption. It was only the connected internet where everyone had access to, and everything was connected with each other, where this adoption really came in. And I believe this is the same for the blockchain industry. And that's why blockchain interoperability is just so important. So essentially, interoperability means the ability to connect two distinct blockchains and give them like the ability to transfer data from one to the other. And the most common example of this data is essentially a token transfer. So here in this illustration, you see we have chain 1 and chain 2. And on the chain 1, we have a token 1, which we want to transfer into the chain 2. Or on the chain 2, we have a token 2, which we want to transfer into chain 1. So this is interoperability. And for me, it's crucial to really reach mass adoption and mainstream adoption with blockchain technology. Just quickly, there are many different terms, chain 1, chain 2. Chain 1 often also mentioned as a main chain or a central shard, and chain 2 often mentioned as a sidechain, a parachain, or a shard as well. So please don't get confused by that. It's just different terms, different projects are using, but essentially they often mean very similar things. I would like to show you like a very quick overview of different methods available today or like being worked on currently. And please, this is a very quick introduction into the topic. It's really just a rough overview, but I think then these terms can help you find more information online so that you can really dive deeper into the whole topic. So the first one I would like to talk about are atomic swaps with HTLCs. So HTLC stands for hash time locked contracts, and they are essentially smart contracts which are responsible to lock the tokens which should be swapped and to unlock them only by revealing a cryptographic proof, which can be then verified by both parties, making this whole swap secure. If the proof is not revealed on time, then the swap will just not happen. And well, this solution here was implemented before by, or was conducted before between Bitcoin and Monero. It's very simple to implement. It's completely trustless because it's directly peer-to-peer. However, it can be slow because both parties have to wait for the other party to reveal the cryptographic proof. It can happen, it cannot happen, so that slows down everything. And like the name already suggests, it's really just an exchange of tokens. So between Bitcoin and Monero, for example, or Bitcoin and Litecoin, it's not really a transfer of a token into a new chain. It's just a swap, and they stay on their distinctive blockchains. The next one I would like to talk about are federated two-way pegs. So with a federated two-way peg token transfer, so this is a real transfer, like these are facilitated by a group of trusted intermediaries, which basically operate a multi-signature account on both of these chains. And with that account, they maintain a peg between the transferred tokens. So if I send one token from blockchain A to blockchain B, I burn them on one, I mint them on the other. That's what this multi-signature account or these trusted intermediaries are responsible for. It's also very simple to implement. It's nothing too groundbreaking. It's quite performant. However, it's limited in decentralization because you only have this multi-signature account responsible for the token peg. So you have to trust these people in that account to not steal the tokens or do something what is not intended. The Liquid network by Blockstream is doing exactly this mechanism or utilizing that mechanism. But I think it goes quite long back in time already, so it's quite an archaic method for interoperability. Another solution which comes up recently quite often in the news, because Ethereum is working on it, but more as a second layer solution, not for like an interoperability protocol between blockchains, optimistic rollups. Here, essentially, a sidechain block is optimistically posted on the main chain. So optimistically means it's just posted there in the hope everything goes good. The main chain is not processing it, but it takes a small stake as an insurance if it's not going good. So then for like a certain period of time, this sidechain block can then be challenged by everyone on the network in case it's invalid. And if that's the case, then the stake, which was before like staked as insurance, goes to the challenger. So there's an incentive to check the network to see if like these sidechain blocks are like valid or not valid, because if they're invalid, the challenger gets some tokens as a reward. But if it's all good, which is like in 99% of the cases always assumed, it gets accepted and that's it. And that's why it's very fast if there's trust between these parties doing this transfer. And it's very flexible because you can essentially like, like take any kind of transaction and do this optimistic rollup with it. There are no real limitations. However, it's a very complex implementation. And if there's no trust between the parties, which I would argue in blockchain is quite often the case because you don't know the other party, then it can also be quite slow because you have to wait for this challenge period to end. Like I said, it's currently being worked on and researched by the Ethereum team as a second layer solution. The other solution I wanted to talk about has quite a difficult name, Heterogeneous Sharding. So in this solution, basically, every shard, which is like a parachain or a blockchain, relies on one central shard for their security and interoperability protocol. This is often also called like pooled security. And as long as the central shard is secure, these other shards are secure as well. And then they can just proceed and post the data which they want to transfer into another blockchain or shard. And the validators on the central shard accept that. Often they don't really process it. They just see, is everything valid? And then like legitimate, and then they accept it. And the sidechain or this parachain can move forward. This is very good for new blockchains being spin up because the developer doesn't have to take care of the consensus algorithm. He doesn't have to find like nodes which secure the network. So that's quite good. And it's universal. It means like it can really accept any kind of transaction or data. However, that is like hugely complicated, not really done before in that scale. And the number of shards which are part of this pooled security is limited. I think Polkadot currently limits it to around 100 people theoretically. Not sure how far they are in the implementation, but that's the number currently going around. And yeah, like I said, Polkadot is working on that interoperability solution. And then the last one I go into today are cross-chain updates, short CCUs. These CCUs just follow a specific data structure, which is then understood by both blockchains. And this data structure carries just multiple information. For example, the transactions which want to be sent to another chain, the approval signatures from the origin chain, the sending chain, that these transactions included are valid. And then obviously all the information from the origin chain as well. And this is extremely fast and efficient because essentially you just collect all these transactions and send them over, post them there, and it's assumed that they are valid because these validators have signed them off. It's very scalable as it's just another transaction, and there's no limitation like 100 parachains maximum. And it's universal. You can do that with any kind of data, any kind of transaction. However, it requires a relayer for these CCUs because they're not posted frequently or regularly. There's no automated system behind it. Essentially, this is just like a package of transactions occurring on one chain. And once someone wants to make these interoperable transactions happening, he has to post that CCU. And it requires a common protocol on both sides. But I guess that's the case for any interoperability protocol anyways. And yeah, we at Lisk are working on that solution. And I would love to give you therefore a little bit more information what that entails. So essentially, like I said already, this cross-chain update, the CCU, contains general chain information and the cross-chain transactions with their validity. And essentially, when such a cross-chain transaction is like posted or sent to the chain one, nothing happens yet. It requires this cross-chain update to collect them and then posting it onto the second on the chain two, which in the Lisk ecosystem often is referred to as a sidechain. And only once it's there, then it can turn final with our BFT consensus algorithm. And after that, directly all the changes apply. So how does it look exactly like when we send a CCU or like want to send transactions from the Lisk main chain to a sidechain? So essentially all the cross-chain transactions targeting this one sidechain are wrapped inside the CCU. and the CCU is then signed by the main chain delegate. So from the origin chain, the sending chain, because they can prove that all these transactions inside are valid. For example, I want to send a token from the main chain to the side chain. They can prove I actually own these tokens on the main chain. And once they signed it and a relayer relayed it to the side chain, it's posted there, and all the effects are applied once this CCU transaction then on the sidechain is finalized. And if we go the other way around, it's very similar. Again, then this time on the sidechain, we collect all the transactions which are intended to go to the main chain into one CCU. The CCU transaction is then signed by the validators of the sidechain because they can prove how much each individual account owns in terms of tokens and so on. And then it's posted by a relayer on the main chain. And once it's final, the effects are applied. So very simple. And what happens if we now want to send from sidechain to sidechain? So essentially, there's no big difference between a main chain and sidechain. That's just terminology. However, in the sense of Lisk, we're building an ecosystem, a blockchain application platform. So we established the main chain as a centerpiece of that ecosystem because it's easier to handle than having native sidechain to sidechain communication in all cases. It's not impossible to do even with our current solution, but we prefer if people always go from the sidechain to a sidechain, from the main chain to a sidechain and back to keep it clean. So essentially, if you want to send, in our case, from sidechain to sidechain, you always have to route through the main chain by just using the techniques I explained before. And yeah, that's a protocol, and it basically enables everyone to either send the LSK token from any chain to any chain within the Lisk ecosystem, but also how we call them custom transactions, which can be anything you can imagine. They can be different, like custom tokens, they can be NFTs, or they can be also just data like Oracle information. And these kind of different custom transactions can then also be sent from one chain to another. In this case, however, one sidechain has to support a specific custom transaction by having the custom module, which has all the code to process this logic, has to implement that as well. The main chain is just a relayer, so it never processes any of these custom transactions. That's why this solution is also so efficient. So essentially, why this cross-chain updates, in my opinion, is the superior method for blockchain interoperability is because of these 5 key points. The last one I just mentioned, it's very efficient as the main chain just relay these cross-chain custom transactions without processing them, but it's also very scalable. Like I already said, there's no limitation on the number of connected sidechains, basically unlimited as long as these cross-chain updates can be posted still to the main chain or the side chain, but that's always just required when it's like when someone really wants to conduct a cross-chain transaction. So it's very flexible in that regard. And because all main chain and side chain delegates or validators are always signing off these CCUs, it's very secure. And obviously it's fast because you just post a regular transaction and wait until it's final. There are no long challenging periods or so involved. But what does it mean? What does this interoperability protocol bring to the people and to these different platforms? So first of all, I would like to talk about why it's so great to build your own DApp on its own blockchain and not on a common blockchain like Ethereum, where like over 1 million smart contracts are deployed today. So essentially, you have to imagine on a sidechain, it's like you have 100% freedom. You can just customize it as much as you want. You can create your own tokens on it, which can be moved easily between compatible sidechains and, of course, on your own sidechain. You can change the consensus algorithm. Initially, we support proof of authority and delegated proof of stake, but anyone can develop their own consensus algorithm as well. You can, for example, change the block rewards. If you have your own token, you can make it inflationary this way. You can change the block time. Whatever you want to change, you can change it because it's your own blockchain. And it's important that when you have your own blockchain, that you are still part of a bigger ecosystem, that you feel this unity. I think that's one of the strongest attributes Ethereum has going for it, that the developer community or overall the Ethereum community is moving forward as that unit. And this is not possible if you have no interoperability protocol. But if you have it, that's possible. In our case, the LSK token is the common ecosystem token. That means you can move it everywhere. You can obviously move it on the main chain, but also into any sidechain. And it's by default always the token for the transaction fees. So if you want to send a transaction inside the sidechain, you have to pay a fee, obviously. And that's then by default the LSK token. And like, as you know, everyone has an address on the blockchain. And as we're dealing here with many different blockchains, we decided to share the cryptography and to share the address system. That means every sidechain, your account is essentially the same. You have the same address, the same private key leading to that, so that it's really seen as one unit, as one Lisk account, and not as an account for all these different blockchains. And with these factors, I think I can really show you with this illustration here now the power of interoperability. Essentially, a user moves LSK, as an example now, from the main chain to an exchange and swaps them for, let's say, a Bitcoin. And this Bitcoin, the user then sends to the prediction market because he wants to bet on, let's say, the winner of the next Nobel Prize in physics. And once this information is available, a different sidechain, an Oracle sidechain, can feed that information over into the prediction market sidechain to resolve the bet. And the user, let's hope, won, and can then maybe send his earned prize money or whatever it is over into the gaming chain to acquire now an NFT for that or so. So you see, it's not really limited in use cases. It's very similar to just using one blockchain, just that you always have to facilitate these cross-chain transactions and then post them or relay them in cross-chain updates. But this comes with certain advantages on the technical side as well. What I always say is, like, you're staying independent, but you're not isolated. And what does that mean? So essentially, independence is perfect in this case because your dApp users are not suffering from other dApps users. What does that mean? So every dApp transaction is essentially encapsulated on the sidechain, and only if you want to move like a token or some data into another blockchain, then you have a cross-chain transaction. But if you, let's say, are moving inside or within this prediction market, then every prediction and whatever transactions they have stay on the sidechain, and any other sidechain and the main chain are not affected by that. So if one sidechain goes viral, like we had it back in the day with Ethereum and CryptoKitties, then all the other dApps are not suffering from increased transaction fees or less scalability overall, because of this fragmentation of transactions. Obviously, the fees are much cheaper. On Ethereum, we're paying right now, not sure, like sometimes $60, $70 or $100 to create an NFT. And in this case, we have similar scalability of like 1 million transactions a day on each sidechain. And obviously then with this system in place, it's much more scalable overall, because also if your sidechain runs into scalability problems, you could just spin up a second sidechain to support the load. And there you might want then to implement a direct sidechain to sidechain interoperability protocol as well. However, it's independent but not isolated. That means all these apps are obviously connected, like I explained before, and they can interact and benefit from each other. But I think the real key to this mainstream adoption I was pitching at the beginning is when you connect one platform to another platform. So I was talking just about Lisk, but it would be extremely powerful if going forward, the Lisk platform with all its sidechains is also connected to the Polkadot platform with all its parachains, or to all the Cosmos blockchains, or the Bitcoin or Ethereum blockchain. because then you can, for example, send any ERC20 token from Ethereum into the Lisk ecosystem and use it within the sidechains which accept these. And I think this will foster so much innovation going forward that we will totally lose overview of what's even happening, even though like today it's already a lot. So that's why I think blockchain interoperability is so tremendously important for the industry, to solve scalability, to bring more the communities together, to not let them be isolated and hate each other's, to foster innovation and all of this. And if you want to know more information about blockchain interoperability, we have an event on the 21st and 22nd of May. It's an all online event, so you just have to go to lisk.io/Lisk.js. We are going to reveal 14 research papers about interoperability there. It's just in 3 weeks, so make sure to register and attend. We'd love to have you there. That's it already with my talk. Thank you so much.
Awesome, Max. Great to know the updates of Lisk. We definitely support the project, and anything to do with JS and WebAssembly, definitely. We're always there. Whatever support and help from India as well, we would need to get for education. I spoke to your teammates back in Berlin as well. We should definitely look into education, especially a lot of engineers are coming from India and Asian markets, and we should definitely build content accordingly. So great, awesome. Thank you so much, Max. Lisk is coming